Hello everyone. In this video I want to share with you my experience of learning Go. For me, Go is a new language. That is, this playlist will include videos in which I simply captured my journey in learning Go. The first thing I tried to do is get a general idea of the technology. I don't like teaching a spherical language in a vacuum, starting with syntax or going down the path of pure practice without any systematization, although I don't think it's a bad method. It just doesn't suit me. I like it when I have an understanding of the laws of this world, and then I study their practical application, delving into the nuances of syntax and industry-accepted patterns. That is, first I form a general picture, and then I consider language as a set of rules for writing code. If you find this format and the topic itself interesting, don't forget to like and subscribe to the channel. Now let's get down to business. Go was developed in 2007 within Google, and its first public version was released in 2012. The main goal of the developers was to create a language that combines simplicity and readability of code, high performance and efficiency, built-in support for concurrency, and an integrated toolchain that provides uniform handling of compilation, dependencies, formatting, and testing. Well, let's install Go and see what we get. To do this, go to the official website. Just in case, I'll remind you that all links, command examples, and code will be in the text version of the video on GitHub. The link will be in the pinned comment below the video. Next, we will download the archive for our operating system. Since I have Linux and I am doing this part of the demonstration on VirtualBox, I will simply copy the link to the archive and download it manually via the terminal. Let's go to the terminal and execute the command. Next, I will simply unpack this archive into the usr local directory. To do this, we will execute the command sudo-tar-C, specify the usr local directory. Also pass the parameters x, z, and if and specify the name of the archive. Next thing we need to do is add the path to the directory with the Go binary to the path variable. To do this, we need to edit the bash file. It is located in the home directory. Open the file for editing. Scroll down and insert the line here, save the file, and then refresh the session by simply executing the su command and passing the value of the user variable. Then execute Go version. Great, Go is installed. Now that we have the ability to run Go binary files, I would like to clarify this issue. Many people refer to this binary file as a compiler, but that is not entirely accurate. To be more precise, the Go binary is a command shell or interface to the entire set of Go developer tools, or the Go toolchain. This reflects the philosophy of the language. All of the developer's basic tools are provided through a single common interface and are available out of the box. If, for example, we look at the world of PHP developers, there is a separate interpreter, a separate composer package manager, separate packages for testing and analyzing code that require Composer and have their own dependencies. In other words, PHP Toolchain does not have a common management interface and is developed by different teams, so the approach adopted in Go can be safely considered one of its advantages. Let's try to structure the Go toolchain a little and organize all the tools. For example, we can build a hierarchy of commands in Go. Let's paste it into the terminal and see. Here we see that after calling the Go binary itself, we can pass it various commands. For myself, I divided them into the following groups: basic operations with code, working with modules, formatting and generation, analysis and quality, tools and debugging, service commands. In other words, we have a shell or interface layer expressed in a set of commands, and we have real utilities that are called under the hood when these commands are executed. For example, a programmer is provided with the command interface go build minus and the name of the resulting file. Under the hood will be called the real utilities. For example, compile, link, and so on, located in the usr, local, Go, pkg, tool, Linux AMD64. All these utilities are included in the archive provided by the official website. I am talking about the archive that I downloaded to install Go at the beginning of the video. In other words, the main point of all the above is that the archive contains a set of basic tools and a Go binary, which is an interface to them. To see all the commands available through the Go interface, use the Go help command. To see the description of a specific command, such as build, you can run Go help build. Alternatively, you can find descriptions of the commands on the official website. In general, I think we have achieved a basic understanding of this issue and can move on. The next step was to look at Go from the perspective of an average abstract project. And in the process, I formed the following picture. The module acted as a kind of whole unit. And since this is the theoretical part, I will move on to the slides. Module is a unit of build, versioning, and dependency management. Now let's try to understand the essence of this definition, first theoretically, then practically. In general, this is a directory with the Go mod file that stores module metadata, such as its name and dependencies. The module includes all subdirectories from the Go mod file to the first other Go mod file encountered. In fact, a project can consist of more than one module. In this case, the project will contain several directories with separate Go mod files. However, the more common option is one project equals one module. Although when developing a public project, if a second version appears, you may need to create a new directory with a Go mod file. We will see this in practice. The module must have a name. It is formed according to the following condition. If the module is published for external use, you need a URL accessible for GoGet, for example, GitHub, Bitbucket, GitLab, or something like internal.company.local/myservice. But if the module is local, any name is acceptable. That is, at the start, we must answer the question, will another Go project ever import this module? If not, you can write any name, CRM, MyApp service. If so, be sure to use a URL path such as GitHub, user service. Now let's touch on the concept of an application. A module can include one or more applications. Applications, in turn, consist of packages. At least one is main or main plus a set of packages from our module or third parties. Applications become separate binaries, that is, a separate binary is equal to a separate application. Let's visualize this a little. Here we see a directory containing a file called GoMod. This is a module. It contains a directory called CMD, which contains two applications, API and worker. Each of these applications will be compiled into a separate binary. In other words, each of them is a separate main package with its own starting point in the form of a main function. Now let's talk about importing packages and the rules that govern how it works. When it comes to external public packages, it is the package itself that is imported, but the module acts as a dependency. In other words, the key point to understand is that importing always works at the package level, while downloading works at the module level. This means that when we write import github.com/user/project/utils in the code and then execute the go mod tidy command, we are saying that we want to import the package, but in fact, Go will install it as a dependency and download the entire module from github.com/user/project. Let me remind you that this was a look at working with imports in relation to public external packages. If we need to import our own packages from our local project, then the import is simply done through the module name. For example, if we have a CRM module, then importing an internal package is done as follows. We write import and then specify the path CRM service name. Now let's talk about versions. When importing public packages, we often encounter situations where there are several versions available, and we need to understand the rules governing this process. This is necessary at least in order to import external packages and either specify the version we need ourselves or understand which one will be pulled in by default. And, of course, this is necessary for those cases when we ourselves are creating a public project and plan to have versions for it. So, when we don't specify which version we need, that is after the keyword import comes github.com/user/project/utils, but there is no v2 or v3 in the path, GoMod will proceed with one of the following options. If version 1 of the imported module exists, the latest available version from the first version range is downloaded. If v1 is not available but v0 is, the latest version from the 0 version range is downloaded. If neither v0 nor v1 is available, a pseudo-version is downloaded. In this particular example, the pseudo version will be a snapshot of the last commit of the default branch. Usually, this is main or master, marked with a date and hash as the version. That is, the form dependency will look like this: module name, 0 version, date, and commit hash. As an addition, I will say that a pseudo version may appear even when the external module already has versions, but when executing go-get, the branch name or commit was specified instead of the version tag. In this case, the pseudo version will point to the last commit of the dev branch. We will also see this in practice. So, if we return to our 3-point rule and illustrate it in more detail, we get the following picture. Let's say that an external module has the following list of versions. When specifying an import without a version type v2, version 1.9.99 will be downloaded and installed as a dependency, namely the latest version within the first one. But what if we are working with a module that has many versions and we need a specific one, for example, 2.2.33? In this case, you first need to run go-get in the following format. That is, we write github.com/user/project/v2 and then specify a specific version. This will result in a dependency in the file of the form github.com/user/project/v2 followed by a space and the version number. Then we can simply use the import github.com/user/project/v2/utils. I will pause here for a moment and draw your attention to the fact that we have now introduced a new way of managing dependencies. This is go-get. That is, instead of the sequence described at the beginning of the conversation about importing and its rules, where first you import the package into the code and then execute go mod tidy, you can simply take a different approach. First, get the module by executing go-get and the module address. This will download the module according to the 3 rules described above and add a go mod file dependency of the type shown on this slide. After that, we can import the package from the previously obtained module into the code. In other words, it's the same thing, but we install the packages ourselves, rather than the go mod tidy command, which simply refers to the existing imports in the code. The main thing to understand here is that these two approaches have the same rules for working with imports. The last thing I will add is that when executing go-get or go mod tidy, the modules will be located in the path stored in the go mod cache variable. We will see this in the practice section. I may delve deeper into this topic in the future, as there are still a number of interesting questions. But I deliberately chose not to go into them in detail. It seems that they can wait a little longer. So now let's move on to the practical part. But I will start this practice with a summary and the resulting project structure. So, let's summarize. First, we installed Go. Second, we understood that the Go binary is an interface over a set of utilities, and all of this comes out of the box. Third, we looked at it from the perspective of a typical project. From this, it became clear that we have a module. This is essentially a directory with a Go mod file. This module can contain one or more applications. Each application is a separate main package from which a separate binary is obtained. Fourth, we understand that a module can have a name and that there are rules for forming it. Fifth, here I touched on imports. At first glance, this transition seems a little abrupt, as if it were out of context. Well, the thing is, while trying to understand the logic behind packages and modules, I realized that this issue needs to be addressed comprehensively. Let's take another look at the whole picture. We have a module with an application in it. This is the main package. The main package can import other packages. That is, in turn, they can also import other packages. Packages intended for import can be part of our module and reside in directories such as internal or pkg, or they can be pulled from the network. It is also important to understand that when we import an external package, Go downloads its entire module to disk, specifically to the directory specified in the Go mod cache variable. However, during compilation, only the specified package will be pulled from this module. It is important to note that packages may have versions, which generates certain rules governing the import of external and local packages and determines how our module will be structured if we are developing, for example, a library that will have versions. That is precisely how I came to the conclusion that this is the understanding that is needed here. Now let's structure the practice. For visualization, I will insert block headers into the terminal. So, in the first block, we will see how one project is equal to one module and how it can contain several applications. The second block will demonstrate that we import a package in the code, but the entire module is actually pulled in. In the third block, we will see how Go behaves when we import packages without specifying the version we need, and we will touch on the additional concept of pseudo-versions. In the fourth block, as an addition, we will see how pseudo-versions can appear if we import by branch rather than by tag. And in the last, fifth block, we will see how to import a specific version from the list of available ones. Okay, let's move on to the implementation. Our first goal will be to experience the module as a project unit and individual binaries as an application. There will be no logic in the functionality of this project, only calls to dummy functions to see that the scheme works as we expect. We currently only have an empty first contact directory. This is the conditional directory for our project. To create the project structure, I will run a bash script. Essentially, I just scripted what I could have done manually throughout the explanation. In other words, I just took a slightly different approach. I will show the script or fragments of it and explain what it does, and then we will run it and analyze the result. In general, let's create a file called block1.bash and paste the code into it. If you look at the code we just pasted, the first thing I do is initialize the module with a regular local name and create a set of directories. This is cmd, which contains API and worker, and the internal directory, which will contain the service directory. I'll make a quick note here. What I am doing now is not a canonical pattern for Go project architecture, although such a pattern does exist, but I think it is worth discussing as a separate topic. I just take fragments that fit my demonstration. For example, the cmd directory as I created in the script is a pattern accepted in the community, but not mandatory. The internal directory, on the other hand, has special functionality. Packages located in it are only accessible within our module, or more precisely, within the parent directory and its subdirectories, but are closed to the outside world. The name of the internal directory is a reserved mechanism and has a special meaning. Next, we create a service file and write the code there. We can see here that the main file of the package has the same name as the package directory. And in the code itself, we see the package name, the import of the package from the standard Go library, and the function, but there is no main function here. The next step is to create the cmd API main.go file. We will also write the code there. Here we create a main package for the API application and import the service package from our module. In the body of the main function, we simply call the function from the service package. Then we create a second application in the cmd worker directory, namely the main.go file, and write the code there as well. In the code, we create a main package for the worker application and import the service package from our module into the body of the main function. We also call a function from the service package. The next step is to build these applications. That is, we first sketched out the structure, and then immediately built it into a binary. To do this, we execute the following three commands. This is make dir. We simply create the bin directory, and then twice go build and tell it that the resulting files should be in the bin directory. One will be API, and the second will be worker. Let's run this script. To do this, execute bash block1.bash in the terminal. After executing the script, you can see that the entire structure described earlier has been created. That is, we have two directories with entry points into the application code, API and worker, and one internal service package. There is also a Go mod file. If we also look at the bin directory, we will see that we now have two separate binaries. Each one is a separate application in its final form. And now, of course, we can run these applications in the terminal. For example, by simply executing the call at bin API. Let's run this binary. As a result, we see the string hello from API. This means that everything worked correctly. In other words, we have achieved the goal set for the first block. Let's move on. The goal of the next block will be to show that we import a package in the code, and the entire module is downloaded in the process. To do this, we need to add a simple external import to the already created module. Let's open the file located in the first contact cmd API directory and add the import there. After that, execute the command go mod tidy. This will cause a dependency to appear in the go mod file. But, as we already know from the theoretical section, to see where the modules downloaded by dependency are physically located, you can execute go and then the name of the variable go mod cache. In my case, it is /home/vysmv go pkg mod. Alternatively, we can run the following command go list m jasongithub.com/google/uuid. Then take the path from the dir field and run the ls command for that path. As a result, we will see all the files of the downloaded module. That is, the goal of this section has been achieved. We saw that we import the package in the code, but the entire module is downloaded, so we can move on. Let's move on to block number 3. Here, our goal will be to demonstrate the rules for selecting a version. To begin with, next to our current module, I will create a directory named dvm, which is a demo version of the module, and open it in VS Code. To do this, I will simply call makedir and specify the directory to be created, and then call the code command. Now we have our locally developed first contact module and a demo version of the public dvm module. We will import its package into our tests. In this block, I will also go down the path of executing a script, but in a slightly more clever way. The demonstration of this block consists of 6 steps, and the script will ask us at each step before continuing further. In general, let's create a file called block3.bash, and let's paste the code into it. The logic here is as follows. We have an ask function that checks whether I want to continue. Next is the local function, but more on that later. And then there is the code for each step. If you scroll down a little, you will see each step being called via the ask function. Now let's move on to a step-by-step analysis of the bash script, its execution, and subsequent analysis of the results after each step. Step 1. Create the module structure and push it to GitHub. First, I initialize the module with the name github.com/vysmv/dvm. Next, create a package and a file called utils inside it. Then, paste the code into it. In the code, we declare the utils package, import fmt, and declare the hello function. Since we will have examples with versions, I also created repositories for the DVM project, so I will also execute the following commands to initialize the repository and push the current structure there. If you look at this set of commands, they are all standard except for the line git remote at origin personal_gh. By default, github.com is used instead of personal_gh. This is because I set up GitHub to work with 2 accounts and specifically configured this process. If you want to see how I set it up, I'll add a link to the video in a pinned comment. And since this isn't directly related to the main topic, let's move on. Let's run the script and enter the password several times. Now let's see what we've got. We have a DVM module with one utils package, and it's been pushed to GitHub. Let's check it out. To do this, let's refresh the repository page. And if we then look at the Go file of the DVM module, the module name will be specified as a URL path, meaning it can be accessed from outside. That's it for this question. Let's move on to the second step. Here we import the package when the external module, in our case DVM, has no versions. Here, I add an import to the first contact module, API application. To do this, I simply overwrite the file first contact cmd API main.go with the following content. Essentially, I just add a new line with an import of our utils package from the DVM module. After that, I execute the following set of commands. Here, I set the value of the Go proxy variable to direct, so that modules are downloaded directly from GitHub rather than through a proxy. I also delete everything from this directory, as I was experimenting before writing this and want to remove all remaining artifacts. For the same purpose, I also run go clean mod cache. The go private variable with the value github.com/vysmv/* is needed to avoid conflicts with version hash sums during experiments. Since you may create a new repository and a set of identical tags several times during testing. This will lead to conflicts if you don't do this export. Performing all these exports in the terminal only changes the settings for the duration of the terminal session. That is, it won't break anything for you in the future. So this is an acceptable solution for the duration of the tests. And finally, I call go mod tidy to pull up the dependency that we previously specified in the import. Great! Now we can enter Y to start the second step. After that, we should see that a dependency with the pseudo version appears in the go mod file of the first contact module. In other words, through this experiment, we confirmed that if the external module does not have versions such as v1 or v2, etc., then we get a pseudo version. Okay, with that settled, we can move on. Next, we move on to the third step, where we import the package when the module has versions from the 0 range. To do this, we will update the DVM module to version 0.1.12 and re-import the package from DVM into the first contact module. But first, before each new action, I will run the local clear function. When I first looked at the script, I said I would mention it later. Let's take a look at it. This simply copies the line with import in the main.go file in the first contact CMD directory and then deletes it. Next, go mod tidy is executed and this line with the dependency is returned. This needs to be done so that before each new launch, the previous dependency is removed, that is, a cleanup occurs. Otherwise, because some dependency is already installed, some tests will not work as we expect, since the import and dependency already exist. I will not explain the meaning of this function further, but will simply call local clear. So, let's move on and add a new function. That is, we will simply overwrite the entire file at the path dvm utils.go. In essence, we are simply adding a new function. After that, we will execute commands that will create a new tag and push the changes. Next, we will execute go mod tidy in the first contact module. Okay, let's take the third step and enter Y again, followed by the password 3 times. If we now look at the go.mod file for the first contact module, we will see that it already has a dependency on version 0.1.12. In short, our expectations have been confirmed, and we can move on. The next step will be the fourth one, where we import the package when the module has a version from the first range. Let's add DVM version 1.0.0 to our module. To do this, we will overwrite the utils.go file in the DVM utils directory again. Here, we will essentially add the function again, but this time under the name new funcv1, and then we will commit the changes and create a tag and push it. After that, we will run local_clear and then run go mod tidy in the first contact directory. Okay, let's run the fourth step. Here, you will also need to enter your password several times. And let's look at the result. In the go mod file of the first contact module, we will see a dependency on version 1.0.0. That is, this test was also successful. I mean, in line with our expectations, so we can move on. Next, we move on to step 5. Here, we create a second version of DVM and import it into our first contact project. First, we run local_clear and then create a new version, namely v2. To do this, we create a v2 directory in the root of the module. In it, we initialize the module with a new name and write the code of the previous version of the package there, but changing the package API. That is, we change the name of the function from hello to hello nawapi. After that, we commit, push the changes, and put the v2 tag on the root of the repository. Then we update the main.go file in the first contact CMD API directory. That is, in essence, we simply install a new import github.com/vysmv/dvm/v2/utils. And finally, we run go mod tidy in the first contact directory. Okay, let's run the fifth step. As usual, you will need to enter your password several times. Upon completion, we will see that a dependency on the second version has appeared in the go.mod module of the first contact. This means that we have completed the task at hand. That is, we have created the second version and imported it into the first contact project. This means we can continue. And now for the final, sixth step. Here, we perform an import without specifying a version from a multi-version module. In other words, we confirm that if the module has a version higher than the first range, that is the second or higher, and there are 0 and first versions, the last one from the first range will be downloaded. To do this, we will perform a cleanup by local_clear and update the main.go file in the first contact CMD API directory, but so that the import is without specifying the version, and then we will perform go mod tidy. Let's run step 6. As a result, we will see version 1.0.0 in the go mod file of the first contact module. This means that the rule described in the 3 points above worked correctly for this case. We have now completed all 6 steps of the third block and can move on to the fourth block. The goal of the fourth block will be to see how we get a pseudo version if we execute something like go get github.com/user/project@dev. That is, if we try to pull the module by branch name rather than by tag. Let's also apply the script to bash here. To do this, let's create a file called block4.bash in the DVM project and paste the code into it. Let's take a look at the script. First, we create a dev branch for the DVM project. Then we overwrite the utils file in the DVM v2utils directory, adding the new func4dev function. Next, we create a commit and push the changes. After that, we clean up and update the import line in the main.go first contact CMD API file, and pull the module through go get on the branch. That's it. Let's run the script and enter the passwords. As a result, the go mod file of the first contact module will have a pseudo version like this. In other words, we have seen another way in which a pseudo version can appear. In general, this block is complete and we can move on. The fifth block is installing a specific version. Let's look at this situation. Suppose DVM has versions 2.0.0, 2.2.33, and 2.5.66, and we want to understand how to install a specific version, 2.2.33. To do this, as usual, we will use a script. Let's create block5.bash and insert the code there. Let's see what we have here. The first thing we'll do is switch to the main branch. Then we'll add a new function to DVM v2utils_utils.go. This will be the new func v2_to_33 function. After that, we'll make a commit, push it, and make a new tag, then push that too. Next, I'll do the same thing, but for another version, 2.5.66. Which means I'll update the utils file in the DVM via utils directory, then push all the changes and the new tag. Finally, I will perform a cleanup and call go-get with a specific version. Okay, let's run this script and enter the passwords. As a result, we will see a dependency of the type v2.2.33 in the go mod file of the first contact module. And if we open the main Go file in the first contact CMD API directory and look at the methods available in the utils package, we will see that the new func v2_to_33 function is available, but new func v2_5_66 is not. This means that we have also achieved the goal of this block. This completes the practical part, and all that remains is the final summary, so left is to record what we've achieved. If we remove all the details, commands, and special cases, Go is built around the following idea in terms of modules and imports. A module is a unit of delivery and versioning. Modules are downloaded, cached, and selected by version. A package is a unit of compilation and import. In code, we always work with packages, but behind the scenes, Go operates with modules. Import, in turn, is a logical dependency, and the go mod tidy and go get commands are mechanisms that bring the logical model into a consistent physical state on disk. Versions are not just numbers, but a contract between the module author and its users. In general, we have everything we need to continue diving deeper and putting together the puzzle of this technology in our minds. To be honest, I don't know yet what the next video will be about. I don't have a pre-prepared plan. This playlist is created naturally as I learn. Anyway, if you found this video interesting, don't forget to like and subscribe. Thank you for watching. Bye.